Hi, welcome back. Yesterday we were working exercise 7.2 till question number 16, I guess, isn't it? So we have to do from question number 17. So we have worked out till question number 16 in yesterday's class. Now we have to start from question number 17. So question is, question number 17. As usual, we'll take I as the whatever the integral given, x by e power x square. X by e power x square dx. So now we'll take the power 1 as t, so that will be easy for us to solve. Let x square equal to t. Now differentiate both sides with respect to x. So that will be 2x is equal to dt by dx. We have only x into dx in the question. Take this 2 to the right side, dx to the left side. That will become x into dx equal to dt by 2. Now the question becomes, in place of x dx, the question becomes dt by 2. That 1 by 2 we can take it out. E power, in place of x square we have taken it as t. So that will become dt by e power t. Take it to the numerator. Since it is negative, it will become positive while we take to the numerator. E power x integration is e power x and we have minus. So write that in the denominator. So e power minus t by minus 1 plus c. Replace t as in terms of x. So we have minus here. So minus e power minus x square by 2 plus c, or you can write it as minus 1 by 2 into e power x square plus c. Either way, the answer will be correct. Okay. Any doubt? Is the screen is clear for you all? Yes, Santini. Hi. Is it clear? Yeah. For taking t, you have to think and take the terms accordingly so that it will be easy for us to find the integration. Question number 18. Integral e power tan inverse x by 1 plus x square dx. As usual, we'll take this as I. So what we have to do now? Take tan inverse x as t, because differentiation of tan inverse x is 1 by 1 plus x square. So let tan inverse of x equal to t. So we will get 1 by 1 plus x square equal to dt by dx. Take this dx term to the left side. So now we got dx by 1 plus x square equal to dt. So in place of dx by 1 plus x square, we can write it as dt. In place of tan inverse x, you can write it as t. Now the question becomes integral e power t. In place of dx by 1 plus x square, we can write it as dt. So this can be written as e power t plus c, or e power, in place of t replace it as tan inverse of x plus c. This is the required answer. Question number 19. Question number 19. I equal to e power 2x minus 1 by e power 2x plus 1 dx. whatever the term you take, either the denominator or numerator, we can't easily substitute. That is, if I take e power 2x plus 1 as t, when I differentiate, I get 2 into e power 2x equal to dt by dx. Yeah. So, e power 2x dx can be replaced as dt by 2. But what I have here, we have e power 2x minus 1. But what we got here, e power 2x. Can we replace here? No. So that is difficult. Or if we split the terms, e power 2x by e power 2x plus 1 minus 1 by e power 2x plus 1, but then also you will find it difficult. For here you can easily substitute, but here you can't find the term to substitute, because here you have e power 2x plus 1 that you have taken it as t, but in numerator, like no, you don't have this term to replace. So that is why if you have split the term also, you can't like easily solve. For that, what we are going to do is, we are going to divide each term by e power x. Okay. So now the given question can be written as e power 2x by e power x, because each term we are dividing it by e power x, so that all the terms contain the e power terms and it is easy for us to substitute in the given question. So it is e power x dx. Now since we have the same base, you can reduce the powers or minus the powers. So this becomes 2x minus x becomes x, and here we don't have any terms in the numerator, so this can be written as e power minus x, and in the denominator again 2x minus x becomes x, and this becomes e power minus x. Now take the denominator as t. Now differentiate both sides with respect to x. So we'll get e power x as it is. Here also we'll get e power minus x. Since we have minus in the power, that will be written as a product. So that will become e power x minus e power x into dx. I am just taking the denominator dx directly to the left side. Now I have the term here. I can directly substitute. In place of e power x minus e power minus x dx, I can write it as dt. In place of e power x plus e power minus x, I can write it as t. So the given question can be written as dt by t. And integration of 1 by t is log t, and t in terms of x can be written as, we have taken t as e power x plus e power minus x plus c. This is the required answer. Here we can't solve the question directly, because if you straight away take the denominator part as t, it is difficult for us to substitute the numerator part. Though you take only 2x as t, you will end up with e power t minus 1 by e power t plus 1. Again you will find it difficult to solve the question. So to reduce the difficultness, we are dividing each term by e power x, so that all the terms consist of exponential term. So it is easy for us to substitute the derivative part, so that we can integrate and we can find the answer. That is what we did here. Any doubt? Any doubt? The same thing, question number 20, the same thing, like no, you have in exponential, both the terms it is in exponential part. So question number 20, I equal to e power 2x minus e power minus 2x by e power 2x plus e power minus 2x dx. Here it is very easy. We can take the denominator part as t, differentiate both sides with respect to x. So that will be e power 2x differentiation is 2 into e power 2x plus here you have minus, so it is minus 2 e power minus 2x equal to dt by dx. Overall we can take 2 as common, it will be in the product, so take it to the right side. So e power 2x minus e power minus 2x into dx, as a whole we have taken 2 as common, so taking that to the right side will become dt by 2. The question now becomes, in place of e power 2x minus e power minus 2x into dx, that can be written as dt by 2. So that 1 by 2 can be taken out of the integration. Dt by e power 2x plus e power minus 2x can be taken as t, and now we can integrate it easily. So 1 by t integration is log t, and replace t in terms of x, as we have x terms in the given question, that is 1 by 2 log e power 2x plus e power minus 2x plus c. That is the required answer. Next, question number 21. I equal to integral tan square 2x minus 3 dx. In yesterday's session we saw that we don't have a direct formula for tan square x. So you have to use the trigonometric identity, that is, we know tan square x is equal to secant square x minus 1, and in place of x you have 2x minus 3. So replace that identity. So I equal to, in place of tan square, we are writing it as secant square 2x minus 3 minus 1 dx. So we have two terms for integration, and we have a formula for integral secant square x, that is tan x, that is tan of 2x minus 3, the whole by. In differentiation you will write it as the product, and for integration you will write it in the denominator. So the coefficient of x is 2 here, so you will write it as by 2. And we have one more term, so that is minus integration of 1 is with respect to x, if you are integrating, that will become x, then plus c. So here we are not like using the substitution part, straight away we are integrating. Or if that is confusing, you can use the substitution part also. Here you will take 2x minus 3 as t, differentiate both sides with respect to x. So you will get 2 equal to dt by dx. Since we don't have 2 in the given question, take that 2 to the right side. So that will become dt by 2. Now the question becomes tan square, in place of 2x minus 3, we have taken it as t, into dx you have dt by 2. So here also you have to use the trigonometric identity. So 1 by 2 will take it out. So I will have secant square t minus 1 dt. So integration of secant square t is tan, 1 by 2 we have outside. So tan t, and coefficient of t is 1, so we don't need to worry about the denominator part. And 1 we are integrating with respect to t, so that will become t. Replace now, so that will become 1 by 2 into tan of, in place of t it is 2x minus 3 minus of 2x minus 3 plus c. This will be your required answer. Any doubt? So either way you can do the question. So now question number 22, I equal to secant square 7 minus 4x dx. So here you will take 7 minus 4x as t, or straight away you can use the formula. So let 7 minus 4x equal to t. Differentiating both sides, will get 4 equal to dt by dx. So given question, secant square t, in place of dx it is replaced as minus 1 by 4, and we know the formula for secant square, that is tan t plus c, and in place of t, you can write it as 7 minus 4x, or straight away if you do tan of 7 minus 4x the whole by coefficient of x is minus 4 here, that you will write it in the denominator part. Okay, then question number 23, I equal to integral sine inverse x by root of 1 minus x square dx. It is very easy. You will be taking sine inverse x as t, differentiate both sides with respect to x. I am just directly taking dx to the left side. So differentiation of sine inverse x is root of 1 by root of 1 minus x square. So replacing dx by 1 minus x square as dt, sine inverse x as t. So you will get it as integral t into dt, that is using the power rule, that becomes t square by 2 plus c. Replacing t in terms of x, you will get it as sine inverse x the whole square by 2 plus c. That is the required answer. Any doubt so far? So now question number 24. There are so many questions in this exercise. There is no other way than to solve. So question number 24, 2 cos x minus 3 sin x the whole by 6 cos x plus 4 sin x dx. How to solve this question? If you see, in denominator can we take 2 as common? So when we take 2 as common in the denominator, that will become, let us as usual take I. So 2 cos x minus 3 sin x by, we are taking 2 as common in the denominator part. So that becomes 3 cos x plus 2 sin x dx. Let's try to take the denominator term as t. So let 3 cos x plus 2 sin x equal to t. Differentiate both sides with respect to x. Now we get, this will become minus, because differentiation of cos is minus sign, and this remains positive, so plus 2 cos x equal to dt by dx. Take this dx to the left side. Now replace in the given question 1 by 2 as it is. Here we get, this can be rearranged as 2 cos x, I am writing positive terms first, minus 3 sin x as a whole into dx, that is dt. So if you see, you will get the numerator term. So as a whole, you can write it as dt. By denominator part, we have taken it as t. Integration of 1 by t is log t. Replace the answer in terms of, replace t in terms of x. So that becomes log of 3 cos x plus 2 sin x plus c. This is the required answer. Question number 25. I equal to, I am just straight away writing 1 by cos square x into 1 minus tan x the whole square dx. So here you have to think which term we have to take as t, so that it is easy for us to substitute. So can we take this 1 by cos square as secant square x? So that will become secant square x, right? By 1 minus tan x the whole square. And if we take tan x as t, differentiation will get it as secant square. Yeah. So now we take, let 1 minus tan x equal to t. As usual, differentiate both sides with respect to x. This is constant, so that will become 0. Tan x differentiation is secant square x. And take this minus to right side. So you will get it as dt by dx. And take that to the left side. So the given question will become, in place of secant square x dx, that can be replaced as minus dt. In place of 1 minus tan x, you can write it as t. We have power 2. Take that to the numerator. So that will become t power minus 2. Use the power rule for integration. That will become t power minus 1 by minus 1 plus c, because minus 2 plus 1 by minus 2 plus 1. So that will become t power minus 1 by minus 1. Already you have minus, so that will become plus. You can take the numerator negative to the denominator as positive. So 1 by t plus c. In place of t, replace it as in terms of x. So that becomes 1 by 1 minus tan x plus c. This is the required answer. Next, question number 26, cos of root x by root x dx. Question number 26, I equal to integral cos root x by root x dx. Obviously, we will take root x as t so that it is easy for us to substitute, because you have root x in the denominator and root x as the argument in the numerator. And if you take cos as t, you will get sine when you are differentiating. But we don't have any sine term, but you have root x in the denominator. So it is difficult for us to substitute the terms for the root x. So here what we are doing is, you will straight away take root x term as t so that it is easy for us to substitute and find the integration. Now differentiate both sides with respect to x. So root x becomes 1 by 2 root x, because this will be x power half. When you use the power rule for differentiation, that will be 1 by 2 into x power half minus 1. When you take the LCM, we will get it as minus half. So we can bring it to the denominator as plus half. Either you write it as 1 by 2 into x power half or 1 by 2 into root x equal to dt by dx. Take this dx to the left side and 2 to the right side. So that will become dx by root x equal to 2 into dt. So the given question can be written as I equal to, in place of dx by root x, you can write it as 2 into dt. In place of root x, you can write it as t. So the given question can be simplified as 2 into integral cos t dt. And we know the integration of cos is sine. So that is simply, since we don't have any coefficients here, that it is 1. So it is just 2 sine t plus c. In place of t, we will replace the term whatever we have taken. So the answer is 2 sine root x plus c. This is the final answer. Any doubt? Question number 27. Integral root of sine 2x cos 2x dx. Let's try to take this root of sine 2x as t, or just sine 2x as t. When we take sine 2x as t, when you differentiate, you will get 2 into cos 2x equal to dt by dx. Since we don't have any two terms in the given question, take this as I. So take this dx to the left side, 2 to the right side. So cos 2x is equal to dt by 2. Now the given question can be written as 1 by 2, because cos 2x dx can be written as dt by 2. Since it is in product, we can take that 1 by 2 to the outside of the integration, and in place of sin 2x it is t. You can write it as t power half or root t, both means the same, into dt. For integrating, use the power rule, that becomes t power 3 by 2 by 3 by 2, because when you add 1 to this 1 by 2, you will get it as 3 by 2. Now, this will become as reciprocal. So, 2 and 2 will get cancelled. So, we will get it as 3 into, replace t in terms of x. That is 3 into sine 2x, the whole power 3 by 2, plus c. This is the required answer. Any doubt? Question number 28. I equal to integral cos x by root of 1 plus sin x dx. Let's try to take this 1 plus sin x as t, and sin x differentiation is cos x dt by dx. So I'll get cos x into dx is equal to dt. The given question can be written as, in place of cos x into dx, you can replace that as dt. 1 by root of 1 plus sin x can be written as root t. Take that to the numerator as minus half. So when you use the power rule, it will be minus half plus 1. So that will be plus half by plus half plus c. So this will become 2 by 1. So 2 into root of, either you can write t power half or root t, both means the same. In place of t, it is 1 plus sin x plus c. This is the required answer. This is just mere substitution and taking the terms for t. That's all. Okay. Any doubt? Am I audible? Can you see the screen and can you hear my voice properly? Please tell me if you can't hear or if screen is not clear. Question number 29. Integral cot x log sin x dx. So let's try to take the argument part. So let t is equal to, or let sin x equal to t. But when you differentiate, you will get as cos x. But here you have it as cos x, sorry, cot x. Yeah. So what we can do is, we can, because here also you have a function, product of two functions. Yeah. So let's try to take log sin x as t. When you differentiate both sides with respect to x on both sides, log differentiation, just like take this as x. So if it is log x, when you differentiate, what you get? 1 by x. Yeah. Instead of 1 by x, you write it as sin x. The chain rule, I guess, you would have practiced in chapter 5. Into differentiation of in the argument, that is cos x equal to dt by dx. And we know cos x by sin x is cot x. Take dx to the left side. So we have cot x into dx, that we can replace it as dt. Log of sin x can be written as t. So now integration of t can be written as t square by 2 plus c. So t can be written as log sin x by, so log of sin x the whole square by 2 plus c. This is the required answer. Any doubt? Can we move on to the next question? Question number 30. Question number 30 is I equal to sin x by 1 plus cos x dx. Here, take 1 plus cos x as t. So 1 plus cos x equal to t. Differentiate both sides with respect to x. So I'll get 0 minus sin x equal to dt by dx. Since we don't have minus in the given question, take this minus to the left side. That becomes sin x dx is equal to minus dt. Now the question becomes, in place of sin x dx, you can write it as minus dt. So minus I am taking in outside of the integration, and 1 plus cos x as t. And we know the formula, integration of 1 by t is log t. Now replace t in terms of x. So that will become minus log of 1 plus cos x plus c. This is the required answer. Question number 31. Question number 31. I equal to sin x by 1 plus cos x the whole square dx. So I will take as usual. Let us try to take 1 plus cos x as t. Let's see whether we can able to substitute in the given question. This will become, it is like a previous question only. D equal to dt by dx. Take this dx to the left side and minus to the right side. That will become minus dt. So I equal to, in place of sin x dx, it is minus dt. 1 plus cos x, it is t. We have power 2. In previous question, we had 1 by t. So we have directly integrated it as log t. But here, we don't have the power as 1. So you have to take it to the numerator as negative. Now use the power rule. So for power rule, you have to add 1, right? So minus 2 plus 1 is minus 1. And denominator also will get it as minus 1. Minus into minus plus. Since you have minus in the numerator, you can take it that to the denominator and replace t in terms of x. So I'll get it as 1 by 1 plus cos x plus c. This is the required answer. In previous question, it was power 1. So we have used logarithmic as the integration of 1 by t is log t. But here instead of power 1, you have power 2. So you have to take it to the numerator. Then use the power rule, that is x power n plus 1 by n plus 1. That is minus 2 plus 1. T power minus 2 plus 1 by minus 2 plus 1. That is t power minus 1 by minus 1. Already we have minus outside. That becomes positive. So that, like, I can leave it as t power minus 1 plus c. But we have furthermore simplification. So you can take that negative power to the denominator as plus and replace t as in terms of x, whatever we have assumed. I hope it is clear. Can we move on to the next question? Question number 32. Question number 32. I equal to minus 1 by 1 plus cot x. Here, if you straight away take 1 plus cot x as t, you will get it as differentiation of cot x is cosecant x minus cosecant x cot x, isn't it? No. Minus cosecant square x. Very good. But it is difficult for us to substitute because in numerator it is only 1. So it is very difficult for us to substitute after the differentiation part. So what we do is we just try to write that cot x as cos x by sin x. Let's see whether we can use in this way. So this can be written as sin x plus cos x the whole by sine. So that will become sin x here. But still, we can't take the denominator part straight away as t. Why? Because we have two terms in the denominator, that is sin x and cos x. But when you differentiate also, you will get two terms in terms of sin and cos. But in numerator, you have only one term. Okay. So what we are going to do? How can we simplify this question? What we can do? If you straight away add and subtract, very good Shantini. If you straight away add and subtract cos x, you will left over with one cos x, yeah? Sin x plus cos x by sin x by cos x. The terms will get cancelled because you are adding and subtracting cos x in the numerator. So you'll have minus cos x by sin x plus cos x. Again, you will end up in the same format. Only difference is in numerator you have sin, here you have cos. Again, like you will add and subtract sign, again this will repeat, like it will be a loop, yeah. What can be done? Before adding and subtracting cos x, we shall do one thing, because we need two sin x terms. For that, you are multiplying and dividing 2. So instead of writing it as 2 sin x, can that be written it as sin x plus sin x? That will be 2 sin x, yeah. Instead of writing 2 sin x, we are writing it as sin x plus sin x. We are just rearranging the 2 sin x as sin x plus sin x for our convenience, so that we can solve the given question. So instead of writing it as 2 sin x in the numerator, as we have multiplied and divided by 2, we are writing it as sin x plus sin x. Is that clear? And now add and subtract cos x. So you'll have 4 terms so that it is easy for us to integrate. Is that clear? Now we will combine sin x plus cos x as one term by sin x plus cos x, that as a single term, plus sin x minus, like we'll write it as 2 integration, so that this 1 by 2 belongs to both, isn't it? So plus 1 by 2 integral, just we are splitting as 2 terms. So sin x minus cos x by sin x plus cos x dx. And here, since both the parts are same, that gets cancelled. Straight away you can integrate dx. And this term, second term, you have to use the substitution part. So for the first term, it will be half into x straight away, or x by 2. Here, take the denominator as t. So I'll get it as, let sin x plus cos x is equal to t. Differentiate on both sides. You will get it as cos x minus sin x equal to dt by dx. Take minus as common, so that because we have sin x minus cos x earlier, so take minus as common. So sin x minus cos x into dx equal to dt, and take this minus to the right side, so that it is easy for us to substitute. So we get half into minus dt by t, that is log t. You have minus half log t. So the first term is x by 2 and plus 1 by 2. Here you have minus, yeah. So now we'll write it as minus 1 by 2 log t. In place of t, it can be written as sin x plus cos x plus c. This is the required answer. Is that clear? Question number 33. I equal to integral 1 by 1 minus tan x dx. The same process for cot x what we did, the same thing. Okay, I equal to 1 by 1 minus sin x by cos x dx. Take the LCM and multiply and divide by 2. So we get 2 cos x, that we can write it as cos x plus cos x. Add and subtract sin x in the numerator, and in denominator you have cos x minus sin x dx. And now split the terms. So we'll get cos x plus sin x by cos x minus sin x dx. Instead of writing, okay, we'll just write as it is. Integral cos x minus sin x by cos x minus sin x into dx. These two terms are similar, so we can cancel those. And here we can use the substitution method. Let cos x minus sin x equal to t. Differentiating both sides with respect to x. This becomes minus sin x, this becomes minus. As we have minus here, write as it is. Differentiation of sin is cos. Take dx to the left side. Take minus as common and take it to the right side. So you will get sin x, because minus if you take, both terms will become positive as both are negative. So now sin x plus cos x into dx equal to minus dt. Now the given question can be written as minus dt by t and plus integral dx. Here there is no need of substitution. Directly you can write it as, because both the terms gets cancelled, numerator denominator. So you can write it as integral dx. Now this integration is minus log t plus integration of dx is x plus c, and in place of t you write it in terms of x. So minus log cos x minus sin x plus x plus c. This is the required answer. Question number 34. I equal to integral root tan x by sin x cos x dx. What can be done? How we can integrate? Any idea? Can anyone tell me how to integrate? We will try to. Multiply and divide by cos x. Very good. So when you multiply and divide by cos x, now what we are going to do is take this cos x to the denominator. That is, writing x as 1 by 1 by x. Okay, we are just rearranging this x as 1 by 1 by x, because 1 into reciprocal of denominator is x by 1. So we'll get back again x. So we are taking this cos x to the denominator as 1 by 1 by 4. So that I can combine sin and cos. So taking cos x to the denominator, that will become sin x by cos x, and cos x is cos square x. We are multiplying and dividing by cos x, and this can be multiplied. Instead of writing here because it is in roots, you can't simplify directly. So I'm taking this cos x to the denominator as 1 by 1 by x form, so that we can combine with sign and we can simplify the terms. So that can be written as root tan x by sin by cos is tan, and this cos square 1 by cos square can be written as secant square x dx. Okay, now you have tan x and you have the bases as same, tan x power half, and in denominator you have tan x, so that will become half minus 1 minus half, so it is tan x power minus half into secant square x dx. So we have simplified to the term whichever possible. Now use the substitution because we have two terms here or two functions here. So let tan x equal to t. Differentiation will be secant square x dx as dt. So the given question can be written as t power minus half. In place of secant square x dx, it can be written as dt. So t power minus half. So when we add the powers using the power rule, so that will become power plus half. So 2 root t plus c. Either you can write 2 into t per half or 2 into root t. Both means the same. Now, in place of t, what we have to do? We have to write in terms of x. So 2 into root tan x plus c. This is the required answer. Question number 35. I equal to 1 plus log x the whole square by x dx. Let's try to take 1 plus log x as t. When we differentiate both sides with respect to x, so I'll get it this as 0 as it is constant, this as 1 by x. Take this by dx to the left side as dx. So you have dx by x as dt, this as t square. When you integrate, you get it as t power 3 by 3, and in place of t it is 1 plus log x the whole power 3 by 3 plus c. This is the required answer. Question number 36. X plus 1 into x plus log x the whole square by x dx. Okay, take, let x plus log x equal to t, differentiate both sides with respect to x. So this will become 1 plus 1 by x the whole into dx equal to dt. Take the LCM, it is x plus 1 by x into dx is equal to dt. That is what we have here. Just rearrange. X plus 1 by x into dx can be written as, take this as I as usual. So this can be written as dt, x plus log x as t. So t square dt. So that will be t cube by 3 plus c. That is x plus log x by 3, and here you have power 3 plus c. This is the required answer. Can we move on to the next question? Question number 37. I equal to x cube sine of tan inverse x power 4 by 1 plus x power 8 dx. I am rearranging this x power 8 as x power 4 the whole square dx. And now let us take tan inverse x power 4 as t. Differentiate both sides with respect to x. So that will be 1 by 1 plus x square. But in place of x we have power 4. So that will be 1 by 1 plus x power 4 the whole square. And dt by dx, I am taking dx straight away to the left side. Now the question becomes dx by 1 plus x power 4 the whole power 2 can be written as dt. And this can be written as sine tan inverse x power 4 as t. So sine t. And what can be done for x cube? Here I have missed one term, that is tan inverse x is 1 by 1 plus x square. But you have x power 4, isn't it? So after differentiating tan inverse, use the chain rule for x power 4, that is 4x cube equal to dt. And take this 4 to the right side. So that will become x cube dx by 1 plus x power 4 the whole power 2 equal to dt by 4. Now the question can be written as x cube dx by 1 plus x power 4 the whole power 2 can be written as dt by 4 into sine of tan inverse x power 4 we have taken it as t. You can take this 1 by 4 outside. Integration of sine t is minus cos t plus c. And replace t in terms of x, that is cos of tan inverse x power 4 by 4 plus c is the required answer. Okay. Can you all understand? Any doubt? Please let me know if you have doubt in the chat box or any question to be done again or to be taught again. Please post it in the comment section. Can we move on to the next exercise? Are you ready? We are moving to the exercise 7.3. I'm just adjusting. Can you see the screen? If no, please put. Okay. Yes. Exercise 7.3, question number 1. I equal to integral sine square 2x plus 5 dx. As said in the previous class, you can't differentiate or integrate when it is in power directly, like differentiation you can't do directly in integration, so you have to use the trigonometric identity. So you have to use the trigonometric identities or the formulas for integration. So now you can write that sine square x, you have to change to power 1. Okay. So we know cos 2x formula, that is 1 minus 2 sine square x, and take this minus 2 sine square x to the left side, so it is 2 sine square x, 1 minus cos 2x, and into 2 you can write it as by 2. So sine square x can be written as 1 minus cos x by 2. So always remember, we are taking this formula from cos 2x. So sine square x can be written as 1 minus cos x by 2. And in place of x we have 2x plus 5. So the given question can be written as integral 1 minus cos of 2x plus 5 the whole by 2 dx. And you can split it as 2 tenths, or straight away you can integrate. So you have 1 by 2. So integration of 1 is x. So it is x by 2 minus cos integration is plus sign, but you have minus here, 2x plus 5, and coefficient of x is 2, and already you have 2. So that will become 4 plus c. This is the required answer. So you have x by 2 minus sine 2x plus 5 by 4 plus c. I'm so sorry. We have missed that 2 here. I'm so sorry. So we have taken sine square x as what we have taken? The formula 1 minus cos, this should be written as cos 2x. That 2 we have missed out. I have missed. So it is 1 minus cos 2x by 2. So here in the given question, it becomes 1 minus cos 2 of 2x plus 5 by 2 into dx. I'm so sorry, I have missed the 2. I don't know why I have left like that. So integration of this 1 by 2 will take it out so that it will not get confused. 1, that is integration of dx is x, minus when you multiply 2 inside, that will become 4x plus 10. So that will be sine of, because integration of cos is sine, 4x plus 10 the whole by 4, because the coefficient of x is 4 here. So you can multiply 1 by 2 inside, that will become x by 2 minus sine of 4x plus 10 by denominator into denominator is 8 plus c. This is the required answer. Next question number 2, I equal to integral sine 3x cos 4x dx. So first rearrange the terms with the angle greater first. So this can be rearranged as cos 4x, because we have to use 2 sin A sin B, 2 cos A cos B, 2 cos A sin B, 2 sin A cos B. I guess those formulas you have learnt and you are by heart with the those formulas in class 11. Replace that here. We have to use the formula 2 cos A sin B. This is of the form 2 cos A sin B. And the formula is sine of A plus B minus sine of A minus B. And here 2 is missing. So take this into 2 as the whole by 2 to the right side. And that the whole by 2 can be taken outside. So I can be written as 1 by 2 integral cos 4x sin x. That is, in place of a you have 4x, in place of b you have 3x. So that is sine of 4x plus 3x, that is 7x, minus sine of a minus b, that is 4x minus 3x, that is x, the whole into dx. Now integrate these two terms, you will get half sine is minus cos 7x by 7. Already you have minus. Integration of sine is minus cos. So that will become cos x and you don't have any coefficient, that is just 1. You can leave as it is. Now we can multiply this 1 by 2 inside, or you can leave it here. Both the ways it is right. I am writing plus terms in the beginning. So that will be cos x by 2 minus cos 7x by denominator into denominator, it is 14 plus c. This is the required answer. You have to be thorough with the formulas, or else it will be difficult for you to solve. Can you able to see? Just a second. I'm so sorry for the interruptions. Yes, we'll continue. Yes, so sorry. I equal to integral. I'm just rearranging as descending order. So cos 6x, cos 4x, cos 2x. So that it is easy for us to use the formula. Okay. This is the I. Now, what formula we can use here? So everything in terms of cos, isn't it? So we can use cos A, cos B formula. So what is cos A, cos B? That is 2 cos A, cos B. Cos of A plus B plus cos of A minus B. And since we don't have 2 here, we can take that to the denominator. In place of A you have 6, in place of B you have 4. So this can be written as 1 by 2. I am taking it as out. So it is cos 6x plus 4x, that is 10x, plus cos 6x minus 4x, that is 2, into we have one more cos 2x outside, into dx. Is that clear? Now multiply cos x inside. So we have two terms here, that is 1 by 2 integral cos 10x cos 2x dx, plus 1 by 2. Here we have cos 2x into cos 2x, that becomes cos square 2x dx. And again you use cos A cos B formula, and you don't have 2 here, so take this 2 to the right side. In place of A you have 10, in place of B you have 2. And also here cos square 2x, as I said before, you have to use the formula. Here 2 cos 2x formula is 1 plus 2 cos square x. We have only cos square. Take this plus 1 to the left side. So that can be written as cos square x can be written as cos 2x minus 1, that is cos 2x minus 1, into 2 can be written as by 2. But you have to see here that it is already 2x. But here you have cos square x. So what you have to do? To get 2x here, we have to write it as cos 2 of 2x, that is 4x by 2. So when we replace, so I is equal to 1 by 2. We are using the formula, right? Integral 10x and 2x. So it is cos of 10x plus 2x is 12x, plus 10x minus 2x is 8x by 2 dx, plus 1 by 2 you have cos square 2x can be written as cos 4x minus 1 by 2 dx. So now this can be written as 1 by 4 integral cos, I am just taking it as separate terms, plus 1 by 4 integral cos 8x dx, plus 1 by 4 integral cos 4x dx, minus 1 by 4 integral dx. So now cos 12x can be written as sin 12x by 12. Already 4 we have. So 12 4s are 48. And cos integration is sin by 8 you will get. So already 4 you have. So it is sin 8x by 32. Cos 4x is sin 4x by 4. Already you have 4 outside. That is sin 4x by 16. Minus integral dx is x plus c. This is the required answer. Either you can leave the answer here, or you can take 1 by 16 as common, or 48 as LCM, or sorry, 48, 32, 16, take the LCM and you can do. Or you can leave here. Anyway, the answer is correct. Question number 4. I equal to integral, if you cannot see, please put it in the chat box, sine cube 2x plus 1 dx. Now we have to use sine 3x formula, because there only you will get it in cube form. So what is sine 3x formula? Sine 3x is 3 sin x minus sine 4 sine cube a. Here you have sine cube a, yeah? Take this minus 4 cube to the left side as plus 4 sine cube. Take the sine 3x to the right side as minus sine 3x. And here you don't have 4 here. So take that 4 to the right side. So sine cube a equal to 3 sine x minus sine 3x the whole by 4. In place of x you have 2x plus 1. That only you have to be careful. So I equal to 3 sine of 2x plus 1 minus sine 3 of 2x plus 1 the whole by 4 dx. You are not integrating, you are simplifying the given question using the trigonometric formula. You have to be careful in that. Now split the terms. So we'll get 3 by 4 sine of 2x plus 1 dx minus 1 by 4 multiply 3 inside. So that will be sine 6x plus 3 dx. Now integrate. The integration of sine is minus cos and coefficient of x is 2. Already we have 4 here. That become minus 3 cos of 2x plus 1. The whole by 2 into 4 will be 8. Here also you will get minus cos, but already we have minus here. So that will become plus. So plus cos of 6x plus 3 by 6 as coefficient of x is 6 here. And already have 4. So 4 6 are 24 plus c. This is the required answer. Any doubt? Question number 5. Sine cube x cos cube x dx. Can we combine? I'm multiplying and dividing by 2 cube because everything is power 3 here. If we have power as same, we can combine, we can multiply the bases. So I'm multiplying and dividing by 2 cube. So that 2 cube sine cube cos cube, I'm multiplying that. So 2 sin x cos x the whole power 3 dx, because we have the formula a power m into b power m can be written as a into b the whole power m. So that property we are using here and multiplying and dividing by 2 cube. So 2 cube is nothing but 8 and 2 sin x cos x formula is sin 2x formula and you have power 3. Either it is sine cube 2x or sine 2x the whole cube. Both means the same thing. So already we have written the formula here. Sine cube x is like, you have, so everything should be written in x form or a form. Here we have written for sine cube x. Here you have sine cube 2x. So in place of x we have 2x. So what the formula will become? It will become 3 sine of 2x minus sine 3 of 2x the whole by 4 dx. You are just using that formula here. Here I am just showing that as I have written already. But in the exam, wherever you are using the formula, write those in the brackets that you are using that formula or this formula or the identities. Now separate the terms. You will get 3 by 4 8s are 32 sine 2x dx minus 1 by 32 sine 6x dx. Now the integration will be both as minus and already we have minus here, that will become plus. And here you will get as cos 2x by 2, yeah? Already have 32. So that will become 3 by 64 minus cos 2x. Here it will become plus. And you have here by 6 it will come. So 6 into 32 will be, here it is cos 6x by 192 plus c. This is the required answer. Question number 6. I equal to sine, I'm just rearranging the terms. So in descending order, so sine 3x, sine 2x, sine x. Like how we did for the question number 3, the same thing should be done for question number 6. And what is the formula for sine A, sine B? That is 2 sine A, sine B. So 2 sine A, sine B formula is, what is the formula? Cos of A minus B minus cos of A plus B. Very good. We are combining these two. So that can be written as we don't have into 2 here in the question, you write it as a whole 1 by 2. I am taking that 1 by 2 outside. That becomes cos of, in place of a you have 3x, in place of b you have 2x. So 3x minus 2x is x minus cos of 3x plus 2x is 5x. Outside you have sin x and you multiply that inside. So 1 by 2, I'm just splitting it as separate terms. Cos x sin x dx minus 1 by 2 cos 5x sin x dx. So here you can use sin 2x formula, that is sin 2x formula is 2 sin x cos x. This 2 you can take it to the left side as by 2. So it is 1 by 2 integral sin 2x by 2 dx minus half into, here you have 2 cos A cos B formula. Sorry, 2 cos A sin B formula. So what is 2 cos A sin B formula? What is the formula? What is the formula? Can anyone guess? Yes. 2 cos A sin B formula is, very good, that is sin of A plus B plus sin of A minus B. So here it can be written as sin of, in place of A you have 5x, in place of B you have x. So it is sin 6x minus, I am just writing it in bracket, sin of 4x dx. Multiply minus inside. So this becomes 1 by 4 integral sin 2x dx minus 1 by 2 integral sin 6x dx plus 1 by 2, and we have by 2 as a whole, isn't it? So by 2, then that becomes 1 by 4, 1 by 4. So integral sin 4x dx. Now integrating, you will get it as minus cos 2x by 2. Already have 4, so it will become 8. Minus into minus will become plus. Cos 6x by, already 4 you have, so 6 4s are 24. Here it is cos 4x by 4 and already we have 4. That will become 16. And this is the required answer. Is that clear? Can we move on to the next question? Okay. Question number 7. I equal to integral. I am just rearranging sin 8x sin 4x as, sorry, sin 4x sin 8x as sin 8x into sin 4x dx. So here we have to use sin A sin B formula that we have used in the previous question, that is 2 sin A sin B is cos of A minus B minus cos of A plus B. As we don't have 2 in the given question, take to the right side. In place of A you have 8x, in place of B you have 4x. So that can be written as I equal to, that 1 by 2 I am taking it outside. So cos of A minus B, that is 8 minus 4, that is 4x, minus cos of 8 plus 4 is 12x. Integrating both cos, you will get it as sine, and 1 by 2 already we have outside. So this will become sine 4x by 4 into 2 is 8, and sine 12x by 12, and here already we have 2, so 2 12s are 24 plus C. This is the required answer. Any doubt in this? Okay. Question number 8 I equal to integral 1 minus cos x by 1 plus cos x dx. So how to integrate this question? Any guesses? We'll use the half angle formula. 1 minus cos x is 2 sine square x by 2. 1 plus cos x is 2 cos square x by 2. This is called as half angle formula. So here you are writing it as 2 sine square x by 2 by 1 plus cos x as 2 cos square x by 2. 2 will get cancelled. Sin by cos can be termed as tan. As power 2 is common, you can write it as tan square x by 2. And we don't have straight away formula for tan square. So we can use the trigonometric identity. That is tan square x can be written as secant square x minus 1. And in place of x, we have it as x by 2. That's all. So it is secant square. In place of x, we have x by 2 minus 1 into dx. So this can be written as integration of secant square is tan x. So tan of x by 2 the whole by 1 by 2. X coefficient is 1 by 2. Yeah? That you will write it here. Minus integration of dx is x plus c. Take the reciprocal. This can be written as 2 tan of x by 2 minus x plus c. This is the required answer. Question number 9. Integral cos x by 1 plus cos x dx. Now tell me how to integrate this. Cos x can be written as here we have cos x, yeah, 1 plus cos x, that is 2 cos square x by 2. Take this plus 1 to the right side. So that will become cos x as 2 cos square x by 2 minus 1. So we have 2 cos square x by 2 minus 1 by 1 plus cos x is 2 cos square x by 2 dx. Now split the terms. So when you split the terms, 2 cos square x by 2, 2 cos square x by 2 gets cancelled, minus integral dx by 2 cos square x by 2. Can we write this 1 plus cos square as secant square? Yes. So dx, I am just taking 1 by 2 outside. 1 by secant square, 1 by cos square is secant square x by 2, and we have the formula straight away, right? So integral dx is x minus half as it is. Secant square is tan, and the coefficient is 1 by 2, and we'll take it as 2, yeah? 2 gets cancelled. The final answer will be x minus tan of x by 2 plus c. This is the final answer. So we have worked out till question number 9 in exercise 7.3. So remaining, that is from 10th question, we will work out in the next class. Thank you so much for all your support. I didn't expect these many students will join, and I'm extremely sorry in between the camera, like live interruption, and also I'm extremely sorry for that one question that I have missed it too. So extremely sorry. And in next class we'll continue with the remaining questions. If any doubt, please post it in the comment section. I will try to take that also as early as possible. Thank you so much.